continuing in stats, what we're looking at is what if we have multiple stages or multiple cases in a single question. So to kind of illustrate what I'm talking about, maybe we're a packing company and we want to look at the time it's going to take to actually ship a product. So we might have multiple stages to that. Like we might need to wrap up the package. And then after we wrap up the package, well, then we have a loading stage. And then perhaps we have the actual delivery stage. And each one of these would have their own time variables, their own expected values for time. And so the question would then be, well, what is our expected value to actually do all of these steps? Is there a way we could figure that out if we know these individual things? And as it turns out, when we have multiple cases, it's actually pretty simple. Our expected values, or our means, because we're going to shift to continuous variables shortly rather than discrete, but our expected values, we can just add them, or if it's appropriate, subtract them, if they're independent of each other. So that means that this stage, this wrapping stage, doesn't impact how long it takes this loading stage, and this loading stage doesn't impact this delivery stage. As long as these are all independent of each other, then we can just add each of the expected values or means without a problem. So in this case, if the expected value to wrap was, say, 5 minutes, and say the loading stage, well, maybe that takes longer. There's lots of things to load. Maybe that takes 10 minutes. And then delivery stage, well, unless we're going all over America, let's say we're just a local delivery company, this could take a very long time. So maybe this is 60 minutes. So what is our expected value to actually deliver? Well, it is as easy as adding these all up, and we get an expected value of 75 minutes for this total situation here. But what about variances and standard deviations? So we just said that our expected values, we can add them. So for example, if we have an insurance policy, and that was an example that we had earlier, was when we had that insurance company, they had, I don't remember what it was, but it was $20. They expected to need to pay out $20 per customer. Well, what if they had 60 customers? Okay, now what's their expected value? Well, I could add this $20 60 times, or I could just simply do 20 times 60 and get my new expected value for all those customers. Variances are going to work the same way as the expected values, again, and they need to be independent cases, but it's very, very important that we note that we would never actually subtract these. So our expected values we could subtract, but variances we're never going to subtract, because we could then end up with a case where we'd have a zero variance. And that just doesn't make sense, because variance is talking about spread, and I don't expect my data not to be spread out at all. Multiple standard deviations. Now we can't just add our standard deviations. So going in the case of delivery, let's just do two. Maybe for wrapping, my wrapping stage, I have an expected value or a mean of 5 minutes. And maybe I have a standard deviation of 2 minutes. And then my, let's say, loading stage. Maybe my loading stage, I had an expected value or mean of 10 minutes and a standard deviation of 3 minutes right there. I can't just add my standard deviations and get 5-minute standard deviation. Let's take a look at why. Standard deviation we generally get from our variance, so our variance is standard deviation squared. So this one would be 4, and my variance here, when I square that, I get 9. And now I have a total variance, because we saw earlier we could add our variances, and I have a variance of 13 by adding those. Now, how do I get my standard deviation from that? Well, I would square root it. So I have square root of 13. So if we check, if I just added this 2 and this 3, and I get 5, if I square it to get my variance, that would be a 25. It's not 13. So it's not consistent. So we can't just add our standard deviations. We have to actually work from the variances only. And if necessary, we can square root back to standard deviation to find out what it is that we need to know. Luckily for now, the questions are not going to be that bad for us. So suppose your store prints a variety of discounts by printing coupons in newspapers, and over time your manager has found that the expected customer discount from the coupons is $15.45 with a standard deviation of 2. So here's our expected value, or our mean, of $15.45 with a standard deviation of 2. And I'm just going to note, if I have a standard deviation of 2, that means my variance is 4. However, this month your store is offering a $10 in-store discount. What is the expected discount and standard deviation? Now, this one's pretty tricky. So we know that we are shifting our data $10, but would that shift our spread? And the answer is no. Shifting this $10 actually does not shift the spread at all. So the devil's in the details there. So my new expected value, or my new mean, is indeed $25.45, but my standard deviation is still $2. Adding a $10 extra discount does not actually increase the spread at all. It's like I took if you think about our 5-number summary. So here's a 5-number summary, and here's my median. Basically, by adding $10, I've taken this data, I haven't changed its spread outness at all, I've just shifted it over some. So now it's over here. I shifted it right, $10. It hasn't become more variable at all. Okay, so let's take a look at one where there would be a change in our standard deviations. So the Getco Insurance Company expects to pay out $200 with a standard deviation of $25. But the cost of parts has risen in average, that should be an average of $10 with a standard deviation of $3. So now we have some variableness going on here. So if I were just to take a look at before, if I'm within one standard deviation of my mean, my $200, I would have 175 to the left, one standard deviation, and 225 to the right, one standard deviation. And when I take a look at the cost of the parts, it says it has risen an average, so there's my mean right there. It's risen an average of $10 with a standard deviation of 3. So at the low end, $7, and at the high end, $13. So what can I expect to happen with my new payout? Well, these are all variables, so yes, my new expected value will be the 200 plus the 10 and give me $210. But my standard deviation, see, this isn't a fixed 10. It's not a definite 10. It could vary with an average of 3. So I'm going to need my variance. So my variance from here is 625. So 25 squared is 625. And my variance here with the $3, 3 squared is 9. So my variances, that's my sigma squared, is going to be 625 plus the 9. So my variance is 634. But I'm asked for my standard deviation here, or I should have been asked. So I need to square root that. So I'll go ahead and do that. So we'll do 634 to the 0.5 and change that to a decimal, so 2518 about. And we notice that this did not have that great an impact on the spread in the long run over here.